So the AI researchers, they used to call winter periods, winter season. Winter season in the sense there is no development. Always there is a big hype happen. Next few years there is no development. So that is a very interesting story. You know that artificial intelligence, the early days people have used logical inferences. They used to write the rules. Okay, it's there is no automated learning scope, but it is like a mechanical automate. We can simply call it as a simple automation, like what people call as a robotic process automation, RPA. You just automated the stuff. Okay, the robotic process automation itself, it does not have a artificial intelligence. That means it should have like a human like a learning strategy. You should have some kind of a human like learning strategy. Whenever you introduce that human like learning strategy, what we can call it as a data driven AI. Otherwise it's simply the rule driven. So the very earlier models, people have started with the rule driven. So slowly they adapted this idea to the data driven. So when they take it to the data driven, different models we call in general machine learning models. Neural network also, it's a part of one of the machine learning, ANN, but it has some exceptional qualities. Because of those exceptional qualities and capabilities, neural network has evolved into a separate subfield. And over the period of time, people have leveraged all the possible capability of the neural networks, a special capability, unlike other algorithms. See, throughout the course, I will ask few interview questions also, or general quiz question. You can call it as a quiz question or even interview questions. Mostly you can expect these kind of questions in the interview if you attend any AI related interview, or even in general conversations. If you have some when you brainstorm with your team or with any kind of intellectual meeting group that happens, certain aspects you should understand, okay, the meaning from the bigger perspective. So to these kind of quizzes, okay, or the interview questions will help you to look at the bigger perspective. So in that sense, whenever possible, you can pen down those interview questions. Definitely you can come around some interesting 50 plus questions, solid minimum. I'm telling you 50 plus interview questions related to AI. Mostly it's a very logical and very practical questions people used to ask. Of course, 75 to 80% of the content which is available in the internet is more bookish oriented. Of course, those things also needed, but apart from that, some logical perspective and more intuitive perspective of certain aspect also you should be aware of it. So if people ask you, okay, tell me, neural network is also a part of one of the machine learning algorithm. Of course, it has some wonderful capabilities, and because of that, people started using it for various applications. That is very obvious. What do you think as a special quality? Okay, you can name anything, whatever you think, as a special quality that neural network is having over other ML algorithms, like whatever you have learned in your ML algorithms. Whether it's a decision tree, or it could be a support vector machine, or a random forest, or a KNN algorithm, K nearest neighbor algorithm. Whatever the traditional machine learning model you came across. Okay, or even a few of you may not be aware of a basic ML algorithm, also not a big deal. But anyhow, I'll be referring to those basic algorithm when I start teaching the mathematics. Don't worry. But those people who have already having those prior knowledge can able to relate and tell me, what do you think one special quality that neural network from the application point of view? I'm asking. I'm not asking anything too mathematical. Okay.
So, sir, sorry to interrupt, but well, I think it works on image data and voice data. That is a differentiating factor, I believe.
Yeah, very good. Yeah. So I can make this point very generic. most of the ML algorithms were very comfortable working with the tabular data sets. You know it very well. Tabular data set is we call it as an N cross P, structured data. Having said that, neural network also handle efficiently the structured data. There's no other doubt. But as Aman pointed out, it has some additional quality that neural network, I can handle unstructured data like images. Okay, whatever you do for the images, you can extend that idea to the video. Video is nothing but a series of image frames only, right? So if you understand the concept related to the images, obviously you got an idea to work with image videos also, not a big deal. Okay, you don't need to separately learn for video. It's inside the for loop, you can process each and every frame. It's not a big deal. Suppose you are learning object detection algorithm for the images, same object detection algorithm you can extend for the video frame also. So the algorithm is basically the same, but it is going to work frame by frame. That's all. Then what we call images as like a two-dimensional data or spatial data. A speech is a one-dimensional time series data set. Speech, audio, a music signal, or any general time series data set. They have certain challenges. Okay. Apart from that, we have, of course, text. Okay, text data. So these are some of the data sets are a bit challenging for the traditional ML model to process it. See, the very first neural network model I have used in 1998, way back, 1998. Those days, there was no buzzword related to AI. Even we don't have a term related to AI. Just we called as a neural networks. That's all. We don't have any buzzword like deep learning, AI. Today we have a buzzword like generative AI, all these buzzwords, right? We used to call it as a simple neural network or artificial neural network. In 1998, 1999, during my undergraduate project, I was working for the neural network for the first time. But those days, we don't have a sophisticated framework like today, Google framework we have a Facebook PyTorch framework. Apart from that, there are other small players also there. They provide a computational frameworks. So the large computational framework which made application possible. So once the application hit the market, right? Once the application hit the market, it created a very big sensation. During 2018, during 2019, nobody talks about large language. Of course, apart from the people involved in this field as a core researcher, either you should be a researcher or a core developer. Of course, you may be aware of this because you are following the technology, you are working on building the model and all. Imagine as an end user, you are, even though you have learned all these technologies, but you are not going to be a developer, but you wanted to use it as an end user, as a customer. You wanted to take this technology and you wanted to fine tune it for a particular application. Okay, you are going to reuse the technology, little bit of customization, and you wanted to take this application. You are not bothered. Okay, what is the technology and the know-how inside this, and you wanted to do some kind of R&D and a little bit tweak the algorithm or tweak the logic to make it slightly different for your application or use case. That kind of R&D you are not going to do. So one side is the developer or researcher, another side is the end users. So the end users, they came to know about all these large language models and applications once it hit the market. Okay, so to hit the market, we required a very large computational framework, and that framework should be scalable, like highly scalable, and people should start using those applications in their day-to-day practice. So that is the reason those days it was not so popular, not known to the common, right? Today, almost even a layman, they know not necessarily they have to use, they have learned artificial neural network or anything related to data science. General, any IT professional, even they were not related to data science, they also have some idea about ChatGPT or large language model. Superficially, at least they know it, right? But those days, apart from the researchers, nobody else have any idea about these neural network architectures. So extending that idea, that neural network has some special capability to handle unstructured data. So let me put the tabular data like this. Okay, this is a tabular data, n cross p. We have image data set. See, I'm giving a bigger picture. Okay, once you give the context, once you establish the context, right? Once I set the learning path, now you will have a clarity which direction you are moving. Okay, so I'm setting the context. The initial few minutes, once you have the directions to move on, you can decide which directions you have to proceed further, where you are currently standing and which directions you should move on. And the one-dimensional data I used to call like this. There are some jargons related to this. Temporal, we used to call this the temporal data. Any general time series data set, you can call this a temporal, one-dimensional. Which are the data sets comes into this spectrum? As I mentioned about speech, audio, music signal particularly, on all other sensor-based data. Sensor-based data comes under the time series. Non-sensor based data also there. For example, daily sales figure, okay, a stock market trading value, daily gold price, daily fuel price variations. They also time series, but they are not non-sensor based, right? And sensor based like a temperature sensor, pressure sensors, vibration sensors, even seismograph. So you have a time series data like a waveform you used to get like this, right? People used to see, is there any specific changes that happen over a period of time? People are interested to monitor this. So this is the temporal information. Your image information is called as a two-dimensional spatial data. We used to call this the spatial data. Spatial and the text. Okay. So put together your speech data and the text, we call this a natural language, right? These guys, okay, these guys. So when I say two-dimensional image, it can be extended for the videos also. Videos, they require a special treatment. People in our generation, okay, we are generation X. Interestingly, we use these data set also before AI become popular. That means what? These are the data sets or challenging data set. Of course, ANN is handling these data set with ease today in modern day. But those days, we were dependent on a traditional ML algorithms. To use these data set also, traditional ML algorithms can handle, but how? You need a special treatment. So to do that special treatment, okay, you need a strong domain knowledge. You need a strong domain knowledge. Luckily, okay, luckily, since I was from electronics and communication background, I had a very strong domain knowledge on signal processing, image processing, and stuff like that. Because of the domain knowledge, we were able to do manual feature engineering. So you need to understand the domain, okay, to apply certain formulas, certain statistical calculations you should apply on the raw data set to represent in the form of features. That was a conventional approach before deep learning became popular. So to apply this manual feature engineering, okay, whether it is an image or the time series, you have to apply a dozens and dozens of formulas, and you work out. Of course, it is an experimentation basis. Okay, a certain group of features will be definitely working for the model. Certain group of features may not be work. You have to do a lot of experimentation. Finally, you have to go for the feature selection, and you have to decide which group of features you are going to proceed with. So whether it's an image or whatever the kind of data, you represent a feature matrix. Okay, this is the manually hand curated feature engineering. Say for example, feature 1, feature 2, feature 3, and so on. As you have extracted 15 features, this is for the image 1, image 2, image 3, and so on. This feature matrix, once you constructed this, this looks like a traditional tabular data, n cross p. N refers the number of rows, p refers the number of attributes. And you can take this guy to a traditional ML model. If you wanted to do a classify the data, classify the images, yes, you can try logistic regressor or decision tree or random forest, namespace, support vector machine. Okay, whatever the machine learning algorithm you wanted to use, still it works. Okay, reasonably, it works. Around 2012, 13, 14, during that time, okay, around 2011 onwards, I can say 11, 12, 13, 14, that was the time there was a very big development that happened in the field of handling these unstructured data, leaving the text alone. Again, a text is is a different territory. Okay, text requires another unique treatment process. Leaving the text, okay, particularly these guys, there is a big breakthrough that happened around 2014-15 as an advent of convolution neural networks, CNN layer, convolution neural network. This CNN layer has completely replaced the manual feature engineering process. What I told, you need a strong domain knowledge to apply this manual feature engineering, right? Even if you don't have a prior knowledge about these domains, okay, by using the CNN layer, you can apply those layers. CNN layer will extract the features from the images as a learning process, and it is going to provide the feature matrix, the series of CNN layers. From there, you can take it forward and you can proceed with convolutional neural network model. So since I'm introducing some terminology over here, okay, so this is being a bird's eye view, okay, complete full picture, and then we are entering into the foundational model. In general, whenever I say deep learning architecture, I say a classical ANN plus CNN architecture. What do you mean by classical ANN? Classical ANN or those ANN, people have used it only for the tabular data set. Whenever you have a tabular data set, whether it is a naturally tabular data set, for example, like employee 1, employee 2, or customer 1, customer 2, you have certain features, right? Your traditional table data set. Or any unstructured data, and you perform manual feature engineering, and then you have got a feature map, right? Feature matrix. This n cross p, this also n cross p. Once you have a tabular structure, your traditional neural network will start, the designing starts from feature 2, feature 3, feature 4. These features are going to act as an input layer to the model. Okay, we are going to have something over here. That is what this course is going to teach you. Okay, what is this block is going to do with this data set, and finally it is going to give the output to you. Okay, whether you do a binary class or multi-class or a regressor problem, accordingly, it is going to provide you the output. So we call this the input and output. This is what your neural network. So according to our requirement, we have to design this. Whether it's the less complex to very high complex, accordingly this design will go on. Okay. For timing, please understand it is going to be a mapping between the input and output, and we are going to have a neural network layers. This neural network layer is going to work on it. So what we call this is the classical neural network architecture, or in modern day deep learning terminology, this is called as FCL. FCL stands for fully connected layer. This is what the fully connected layer. But when you say in a bigger picture, deep learning model means which emphasize the end-to-end design. Okay, end-to-end design starting with a CNN layer followed with so many stages which supports CNN layer, and the CNN layer is going to provide you a feature matrix. Okay, and we do a process called flattening process. Why a flattening process? Because the feature I have to provide it like a vector form. Okay, say for example you provide one image here, one image over here. It goes on to this. You know, the CNN layer purpose is to provide the feature map. This feature map it's converted 2D to 1D. Once it is flattened, it looks like individual features. From here onwards, you can tie up these input features to your traditional neural network layers. Okay, and you do whatever you want in the output. Okay, whether it's a regressor or a binary classifier or a multi-classifier. So this portion, okay, this portion alone is called as a fully connected layer. The moment you get flatten it, so this is the classical design. The rules, the formulas, the ideas will never change. This one. However, the modern architecture you do, this remains static. And here you have a set of different process will go on. Okay, since we are not going in detail about this, but whoever have some prior knowledge, you may encounter some different layers like a max full layer, rectified linear unit activation, and so on. Some series of process you do to get this feature matrix. And so this is the CNN portion, mainly the feature. This is the automated feature learning process, I can say. What happened from the manual feature engineering to automated feature learning process, that your convolution neural network has provided that capability. So people have used this idea for two-dimensional images as well as for one-dimensional time series data. Why particularly these two? Because whether it's a two-dimensional image or one-dimensional time series, there is one characteristic is very common. What do you think that one common characteristics between these two guys? Again, interview question, quiz question. What do you think there is one common characteristic for this? Whether it is an image or it's a video or it's a time series? So don't worry, it's whether it's a right or wrong. Okay, we are here to mutually learn from each other. Okay, it's a learning process. Don't hesitate. You can answer in the chat box also. You can put your answer in the chat box also. What do you think? What might be the common characteristic between these two? They are highly dash. Highly redundant. What do you mean by redundant? Because whenever you look at the picture, look at see my video frame, you see there is the background. The background, there is a white wall. In the white wall, how these pixels are represented, like 200, 210, 215, 205, and so on. These are all redundant pixels. Okay, the details are very few, but most of the places your pixels are highly redundant. Again, your one-dimensional data also, whenever I speak, okay, my speech signal is being plotted like this. Okay, not every time instant my sample is very critical and useful, right? Even if I reduce these samples to very few samples, still I mean I'm can able to comprehend what I spoke. Similarly, this image, even if I downsample it, I try to represent with less number of pixels, still you can comprehend whether it is a tree or it is a boy or it's a car. So that is why we call it as a redundant. So the raw information is always redundant. So when you do feature engineering, okay, you are trying to convert your raw information into more meaningful features or patterns or orientations, and we provide to the model. That means instead of passing the raw information, your model is going to learn from meaningful features. People may ask a question over here, without this, okay, can I flatten this entire 2D or the entire one-dimensional sequences? Okay, instead of flattening this feature map, let me flatten my raw pixels. Imagine I have an image of 100 cross 100, which boils down to 10,000 pixels, right? Still, you can design a neural network model without the CNN, like a traditional fully connected layer. See here, I have not done a manual feature engineering. Rather, I simply converted a raw pixels, 100 cross 100 matrix into 10,000 raw pixels, and you can design a fully connected, a classical neural network like a pixel 1, pixel 2, pixel 3, and so on, 10,000 pixels. Okay, you can build, you can construct a neural network. Still, you can train and tune the model. Your model will learn in a crude way. Still, it will work to some extent. But the kind of input you provide is highly redundant and raw. Okay, so that is why your neural network will find it very hard to learn this. So as much as possible, just because I have a very powerful weapon, I should not give a garbage in, right? This is something like a garbage, because too much noisy, too much raw information, too much redundancy. So even though we have a powerful weapon, as much as possible, we should try to give a more refined quality input to the model. Obviously, your model will be doing a magic for us. Model is going to work in a meaningful way. It is going to learn these pattern and is going to map onto the kind of target we are working. So these are some of the terminologies when we talk about neural networks. What is a standalone, a classical ANN model, typically a fully connected model. When people talk about deep learning architecture, they used to call it as from end-to-end design, including the CNN. Okay. Having said that, if you ask me, sir, using a deep learning architecture in a modern day deep learning architecture with TensorFlow Keras, it is possible to handle tabular data set. Of course, in fact, in Kickstarter AI, we are not going to deal with any images. We are not going to deal with any text. We are not going to deal with any speech. We are going to handle only the tabular data. How come using a TensorFlow Keras framework, which is already, it is equipped with the capability of the CNN layers, whether you wanted to use image means convolution 2D, if it is a one-dimensional time series, you will be using a convolution 1D and so on. Even though if you use the TensorFlow Keras framework, okay, you can skip these stages. You can skip these stages and directly you can go and design a fully connected layer, because we are going to use a tabular data set. Please make a note of it, because we are going to use a structured data. Okay. Okay, the next question comes. Okay, now you are going to use a structured data. What is the requirement for the neural network? Just 10 minutes before only you told neural network has a special capability to deal with unstructured data. Obviously, this is not LLM course. This is not a computer vision model. We are going to deal with either images or to deal with text data. Obviously, it is a foundation model. So the foundation model, we are going to uncover the mathematics behind the basic fully connected architecture of a neural network, the working philosophy and stuff like that. So having said that, neural network has a powerful handle the unstructured data, on what context I should use for the tabular data set, which is being a structure, even though I have a variety of other options like a logistic regressor, linear regressor, decision tree or random forest, distance-based model like a KNN model. Of course, neural network model. Here I'm going to call this a fully connected layer. By the time you know the reason behind why it is being called as a fully connected layer, isn't it? You know the reason why. As a classical ANN architecture. Now to the context of a tabular data set, what could be the specialty of using neural network here? Again, I reframe that question, right? Earlier, I framed the question, what is the specialty of ANN? You told that specialty of ANN is to handle the unstructured data. Obviously, it's correct. That is the strength. Now, keeping all the unstructured data set aside, now we are going to focus on the tabular data set. Okay. So in the tabular data set, what could be the challenge? That's the next level of question. What is the challenge generally?
Sparsity.
Sparsity.
The performance is significantly better.
Performance. Okay. So this is something like a super weapon. Like before ANN, what we used to do, whenever I go and handle some case studies for some boot camps and all, okay, I start with some a banking related problem or a retail data I'll take or some healthcare data set. My audience used to say that, sir, directly why you waste time on this? Directly go for gradient boosting. It is going to be a super performance. You just skip all these models. We'll jump into the gradient boost regressor or gradient boost classifier. It is going to give a outperforming result. Obviously, definitely, we go and choose the more powerful algorithm, which is going to give a very high performance. Obviously, for the performance is the reason. When we look from the data perspective, okay, from the modeling perspective, of course, this is going to give a very good performance. There is no doubt at all. By looking at the data, okay, what data demands? That's the question we are going to ask you. What does the data demand? This is something like the senior professionals, okay, like a project manager level. Imagine you or a product manager, or you are going to bring business to the organization. Your client will have a data, but don't have any idea about what to do with this data. Many of my clients approach me like this. Okay, there are certain clients come with a very clear idea, clear vision. They have their own in-house data science team. They come with a clear requirements. Another 50% of the client, they wanted to use AI, but they don't know what to do with the data set. They have only one goal. They wanted to implement AI, whether it's a AI or generative AI. They come with the data. So your initial investigations, you need to understand what does the data demand. Of course, you are all familiar with exploratory analysis, how to do the EDA and all. You understand the variables, understand the business requirement, understand the business process. You try to understand what is the business process, whether it's the banking process or it is a logistic process, or the organization is dealing with any kind of data security, or whether it is dealing with the healthcare or clinical data. Try to understand the business process and try to understand the variables. And usually you try to explore some EDA, exploratory analysis. You try to ask three questions. Okay, three questions generally. What are all the three questions? All these discussions are taking as where. Okay, you'll be wondering why we are doing this discussion. All these discussions are why neural network model to the tablet instead. Okay, we are trying to get an answer for that. So what happened? What will happen? Third question is little tricky. Okay, that is not usual. Okay, but however, let me write it. How can we make it happen? How do you look at these three questions? How to address this? What is the meaning of this? What happened means you try to understand the business process, isn't it? We are trying to understand the business process. How do you try to understand the business process to get an answer to the question what happened? Generally, what we do.
Explore the historical data.
Very good. EDA. Okay, we
Yeah.
generally do the exploratory analysis. So exploratory analysis is going to give you the insight about the business process. Okay, the companies we are working on the historical 10 years data. So for what is their, which month they make a high revenue, which are all the factor affects their revenue. Okay, which month they get a high sales, what kind of discounts they use, what kind of products they use, which product is a high revenue generation product. All these analysis, you try to answer what happened. Okay. Next, you move on to the next question, next level of question. What will happen? Now you are moving from the exploratory analysis stage to predictive analysis stage. You wanted to try to explore the connection between the variables. You try to explore, is there any potential dependent variable is there on the data? Try to interact with the client. Do you need any variable need to be predicted? If that variable is being predicted, will it add any value addition to the business process? So understanding the business context, just because that variable is having some mathematical relationship, just like that, like in a classroom situation, how we build the model, like that, it's not just because we know the technique, we should not go and build a model. Okay, just looking at the correlation matrix, okay, this variable is having highly correlated, let us build the model and all. First of all, we need to make sure that whether that variable will make business sense or not, whether predicting this value will make sense. So understanding the business process, try to find out, is there any potential dependent variable? Say, for example, this is the variable number 1, this is variable number 2, variable number 3. You interact with the client and see which variable, if we try to predict, it could add value to the existing business process. Say, for example, your client says that, okay, Y2 is very crucial. If you predict this Y2 in advance, maybe, okay, this value, based on this value, we can make some strategical decision process in our day-to-day business process. If this is the requirement comes, then naturally you try to explore which are all the variables affecting Y2. You start exploring it, isn't it? Some variables are numerical, continuous in nature, some variable are categorical. Again, you try to do some bivariate analysis, some statistical relationship. So you try to bring something like Y as a function of X. Here, what is Y? Your client requirement is Y2 as a function of which are all the independent variable affecting this Y. You try to build some kind of model. Again, nature of the Y, whether it's a continuous means regression model, it's a categorical means you classification model, you'll explore. So I'll come to this third point a little later, after a few minutes, after 4 to 5 minutes. When you explore this stage, right? When you explore this stage, how each and every variable affect this Y2, okay? You may end up with two kind of solution. Make a note of it. You may end up with two kind of a solution. Apart from what algorithm you are going to choose, that is secondary. Okay, leave what algorithm you are going to choose, that is secondary. When you try to explore Y2 as a function of X, you are exploring different set of features. Okay, what are the two kind of exploration we can make after doing this analysis, this level of bivariate analysis? what are the two key decisions I should take here? Only what is the algorithm we are going to see that is different. Okay, of course, we need to explore different algorithms. Before you choose the algorithm, what are all the two key findings you will discover, you need to understand at this stage? You can also chat. Okay, you can answer in the chat box also. Any idea?
It tells how is y affected by a change in x.
Yeah, suppose if y is a continuous variable, a numeric versus numeric, a numeric versus numeric, we used to use a scatter plot. Okay, and of course this is numeric and this is categorical. You use a category wise box plot and stuff like that. You try to understand some means these variable is affecting y, and also you have some decent correlation score. You decided to take those variable into the model. Okay, individually you understand how these each and every variable affect this y, and overall you have to arrive a conclusion, right? Okay, this data set is telling something. When I try to discover this, how x1 affects, how x2 affects x3, your bivariate analysis in the form of scatter plot or category wise box plot, or maybe if y also categorical, maybe bar plot or a crosstab analysis, all those things are going to give you some insights, right? What is that overall picture I'm asking? Of course, each variable, how it affects you, get to know that. Overall, you have to make two judgments, isn't it, at this stage? What are the two critical judgments over here? Okay, let me give a simple, okay, to kindle your thought process, let me give two graphical representation. Assume your y is a numeric variable. Okay, one of the variable, say for example, your y1 is having this kind of relationship. Assuming y is a numerical, it helps decide if the feature impacts the decision. Yeah, we are trying to get that, whether the feature impacts. What I'm trying to convey over here is, if the majority of the features, okay, some features are partially impacting, some features are having a very good correlation score, some are moderate, some are very weak. But when you try to visualize, okay, when you try to visualize, if you find that majority of the features, say for example, this is having like a curvilinear trend, this is also a curvilinear trend, and this is highly scattered. Obviously, the correlation score is somewhere around 0.02, something like that. Okay, so except some 10 to 20% of the feature, the remaining 80% of the features having a non-linear trend, isn't it? Having a non-linear trend with your dependent variable. You have to make a judgment over here whether you need to go with a linear model or non-linear model. You got it? This is the two questions you should decide here at this stage. Do I require a linear model or I require a non-linear model? Whether my data demand a linear model or my data demand a non-linear model. How to arrive on this? Of course, to do the bivariate analysis, you have to do lot of not beyond the graph. You have to get some scores also, some statistical test also. All those things. When you have learned overlearned machine learning formally, all the foundational models, you came across something called assumptions. Okay, checking the assumptions. If it is a numerical variable, is that strictly near normal distribution? We have a bunch of assumptions. There should not be any multicollinearity effect in the data. We have a half a dozens of these assumptions. Only if these data satisfy these assumptions, then only this data is eligible for the linear model. What are all the linear models available in our hand? What are all the linear models available in our hand? Linear regressor, isn't
Linear
it?
regression.
If it is a regressor problem. If it is a classifier problem, we have logistic regressor, which is a linear in nature. One more model is a naive Bayes. Naive Bayes also a linear characteristics. Naive Bayes. So we have a two solution under the classification. We have one solution under the regressor, linear regressor. And if it is a classification problem, either you can go with the logistic or naive Bayes. Now come to non-linear models. So your data is not satisfying your linearity assumptions. Okay, your data is skewed. It's skewed. It's not following near normal distribution. And when you try to build a linear model and you try to get the residue of the linear model between y minus y cap, you collect the residue, right? You plot the residue. Residue is highly skewed, which indicates that your data does not fit for linear model. So you decided to go with the non-linear model. So when you decided to go with the non-linear model, okay, under the regressor, what are all the possible solution? You can go with KNN regressor, right?
Yeah. Tree-based
Go
model.
with decision tree regressor. You can go with the random forest regressor. You can go with support vector mission regressor. On the other hand, if you wanted to go with the classification model, again KNN as a classifier, decision tree as a classifier, or random forest as a classifier, support vector mission as a classifier. Even I can include neural network as a classifier. Here also you can include ANN as a regressor. ANN as a regressor, ANN as a classifier. Now we are trying to boil down to the answer to the initial question, whatever we have asked. Why particularly the neural network for a tabular data? Okay, one portion of the answer we discovered. Why we decided the neural network for the tabular data set? Of course, whichever the tabular data set is challenging in the sense which is very challenging for the linear model to solve. Okay, of course, when we discover the relationship between the variables, we are not able to get a linear relationship. So we have got a nonlinear relationship. So we decided to go with the nonlinear model. The next thing is, again, for the nonlinear model, you have a bunch of other algorithms like a KNN, tree-based model, support vector missions. Why particularly ANN? Just like I told you, like a gradient boost algorithm, how it gives outperforming results. Obviously, ANN, according to the complexity and challenge, okay, you can keep on extend the flexibility of the model. To a certain extent, these models can handle nonlinearity only to a certain extent. Of course, these guys also can handle nonlinearity. Very highly challenging. Okay, I can say moderately challenging and very severely challenging. To moderate level nonlinearity, of course, these guys can handle. And if the challenges go beyond certain level, obviously ANN is a solution. Of course, it is a very powerful weapon, as I mentioned. In what way ANN is going to act as a powerful weapon? That is what we are going to discover. What is that special capability ANN is having? These guys are not having. Any quick answer? It is too greedy to ask this question here. But as out of curiosity, I'm asking.
So with reference to this, my understanding is, first of the thing is, as the complexity increases, it performs better, but also at the same time, as the data sample size increases, that is also going to fuel better performance in ANN.
Okay, great, good insight. For the big data problem, yeah, obviously ANN is going to have a better performance. One is data also growing. Unlike a traditional nonlinear model, your neural network model can be able to handle effectively when that complexity challenges increases.